Okay, the Cauchy principal value sense exists. Okay, the function exists. That means the function is bounded. Is bounded means that exists at a single point here or at this point also. There are two or more than 2 points, and this is not general sense. The function exists in general sense. So this this integral exists in general sense. In general sense, if the function exists at one or more points. Okay, at one or more points, then this is in a general sense. Note the principal value. If I take epsilon tends to 0, delta tends to 0, that means epsilon equal to delta in that situation. That means a to b, the function will be at action points. In that situation, epsilon 0, delta tends to 0, both tend to 0. So action will be cancelled out. So a to b within this limits only, it will come out as a to b. In that situation, that is known as the principal value. So at a single point, the function will exist. That is known as principal value here. So at action point only, the function will exist. If epsilon tends to delta, in that situation, this is 0, this is 0. This is only action points. So at action point, at single point, a function exists. That means this one principal value. Since the function exists, improper integral exists in a single sense or in a principal value sense. This is not a principal value sense. Now let me take second condition here. If epsilon tends to or epsilon equal to delta, okay, and epsilon tends to 0 as well as delta tends to 0. In that situation, okay, the improper integral, okay, let me write here the improper integral here, the improper integral will exist at x equal to x1 only. Okay, so at this point x1, well in that situation x1, x equal to x1 only at single point, the function will lie. So that is the principal sense. That is the principal value sense. X equal to x1, sorry, will exist at x equal to x1. Sorry, at x equal to x1. Okay, so or we can write it as a to b fx dx is equal to limit epsilon tends to 0, epsilon tends to 0. This is a to x1 only. So here epsilon tends to, this is x1 minus epsilon. Okay, fx dx. Fx dx plus this is x1 plus epsilon 0, There are only x1 here. This is b here. This is fx dx. In this situation, epsilon. That means these two values will be cancelled out. So at x1 only a to b limits will be there then. So at x1 point only this function will exist. So this is known as principal value. At single point function will exist. This is known as principal value sense. So the function will exist in principle. This is known as second theorem of Cauchy's theorem. Okay, Cauchy's second principal value theorem. Cauchy's principal value theorem. This is in general sense, that is principal value theorem, and that is general value theorem. Okay, so this is general value theorem. This is known as principal value theorem. Second kind here. This is second here, principal value theorem. Principal value theorem. Okay, so this is Gauss's principal value solve, second one. First one was Gauss's general sense value solve. Okay, and this is principal value solve. So these are the two Gauss's principal value and general sense value. This is theorem. So these are the two forms of Gauss's. Now let me solve the questions here. What are the, this is general sense. We have taken principal sense also, we have taken of Gauss's theorem, that how when epsilon tends to delta or epsilon is equal to delta tends to 0, that means in that situation there will be only principal value, one value, and that function will exist. That is known as principal value theorem. Now let me prove these questions and solve these questions one by one. Okay. So first one, we have defined what are the characteristics of first kind of improper integrals, second kind of improper integrals, third kind of improper integrals. And I'll take example, these illustrations here, questions are given here. Let me define that why. The question number second, let me take now. Question number second says that 0 to infinity, this is cos x into dx. Now, is of which kind of improper integral? Now this is first kind of improper integral. Why? Well, limits are infinite. This is first condition is this is of first kind of improper integral. Simple. First kind of improper integral. First kind of improper integral. Why? As first condition, limits are b tends to infinity. So at least one limit is infinite limit. It tends to infinity. So upper limit tends to infinity. So this condition is for first kind of improper integral. Now cos x exists because integration of cos x is sin x, and within this limits 0 to infinity, sin x will have some positive values also, because at 90 degree, if I take 0 to, if it is in defined 0 degree, at 0 degree sin 0 is 0, okay. If I substitute the limits here, within 0 to infinity, there are a number of other angles like 30 degree, 60 degree, 45 degree, okay, 120 degree or 180 degree, etc. So at 180, okay, sin is 0. But within this limits, these, there are a number of other points, angles between 0 to infinity, at this sin x will exist. They have, this function is bounded, but limits are infinite. Okay, so the function is bounded, the integrand is integrable, okay, will have some values, and let me write here, and the integrand or the integral, let me take the integrand here, the integrand is bounded within the limits 0 to infinity. Why? Because if I integrate this function cos x dx 0 to infinity here, okay, this will be sin x, positive value, 0 to infinity. Now if I take limits in between, if I take, let me take sin x, and first limit is, let me take 0 to 30 degree, okay, 30 degree to 45 degree, etc. At number of points, the function will have some values, okay, and this is plus value, and then this is again sin x, integration 30 degree to 45 degree, if I take in degrees, let me take, okay, and so on. At number of points, the function will be bounded here, and up to infinity finally, sin x will be the last limit, let me take here, another point 180 degree to infinity. At these 2 points, the function will not lie, because at 180 degree, sin x is 0, sin 180 degree is 0, and this is infinite, sin infinity is not defined, okay. So, but within, this range 0 to infinity, sin x will have some values, okay. So this is what you call bounded. Function is bounded within this range. This is the first kind. First kind of improper integral. The question number second is a first kind of improper integral because limits are infinite. At least one of the limits is infinity. This 0 to infinity. So this is the first kind of improper integral. Cos x is defined, integration is defined. Integral by substitute the limits between these two points. If I take one real number in between, at that point sin x will lie, and sin x will have some value. So this function is bounded. Proper improper integral of first kind. Okay, so this is first kind of improper integral. Second question is done. And let me talk about third type. Third question I will. What is the question third? It is of which kind of improper integral? Let me check it. So third question. Now it says 0 to 3. So limits are finite. Second kind of improper integral. Now let me check what is this one. x1, x minus 1. So function is maybe unbounded, but function may be unbounded at least at one point. If it is unbounded at least at one point, so this is of second kind. This is of second kind of improper integral. Second kind of improper integral. Why? Let me define it. Since limits are finite, that is 0 is less than x is less than or equal to 3. Within this range 0 to 3 the function is finite. Okay. Second point, integration of let me take 0 to 3 here. This is log of x minus 1 integration, sorry. Still it is dx upon x minus 1. Integration will be log of x minus 1. If I write here 0 to 3, okay, within this limit. Even if I take 0 to 1, 1 to 3, in that way also log 1, 1 will cancel out. But 0 to 3, within this limit, the function will be unbounded at 0. Because at minus 1 is 0. First is at log minus 1 minus, sorry, upper limit first we have to sorry. First is upper limit, that is 3 minus 1, and then is log 0 minus 1. This is log 1 positive, so this is 0. But this is log 2. 1 is finite value, but this is 0. At least one value is not bounded, is 0. Okay. Or does not exist. So at lower limit it does not exist. So at even if I take 0 to 1, at 1 minus 1 it will be 0. That is not defined. So at, let me write here. So at lower limit, at x equal to 0, it is not defined, or is not bounded, is unbounded, or is unbounded, has singular point, is unbounded, or having singularity at x equal to 0. Okay, so it is unbounded, function is unbounded, and the limits are finite here. That means function is of improper integral of second kind. This is improper integral. Two conditions are satisfied. First, limits are finite. Function is not bounded at least at one point. Okay, so it is not defined or is unbounded at x equal to 0. Here it is log 1 is, well, minus 1 we can take before, this is plus log 1 is 0. So this value is 0, is not defined, not having value. So this is okay of second kind of improper integral. Third question is second kind of improper integral. This is of second kind of integral. Improper integral. Alright, so this is question number 3. Now let me talk about fourth question. What does fourth question say? Now let me check it. Function is discontinuous. We say function is not bounded, that means function is discontinuous. at a single point. Otherwise, function is continuous in case of first one. It was existing, okay, it bounded, that means continuous, convergent. Function is convergent at a point, but in case of this, function was divergent, or not having any value, does not exist at a point, but limits were finite. So this is of second kind. Now fourth question. What is the fourth question here? It is 0 to infinity, first condition satisfied, and dx upon it is 1 minus x whole square. Okay. So if I integrate this, let me integrate this function. Okay. So this is it having both the conditions, both the qualities or conditions? Let me take here 1 minus x. If I take, let me substitute here. Let 1 minus x equal to t. No problem. So this is here. So differentiating it with respect to t, differentiating it with respect to t, we get, what do we get here? This is minus dx equal to dt, or dx equal to minus dt. This is 0 to, and limits are here. If I put 0, so t equal to 1. So it is limits are, let me change the limits also. So at x equal to limits, at x equal to 0, t is equal to 1. And at x equal to infinity, it is infinity. At x equal to infinity, 1 minus infinity means infinity is minus infinity, it says. Okay, so it is 0 to infinity, because it is 1 minus infinity. Alright, so at t equal to x equal to infinity, let me write here, at x equal to infinity, it is minus infinity. Minus infinity plus 1 means minus infinity. X equal to infinity, okay, t is equal to minus infinity. Okay, even if we integrate this simply by taking in the, okay, above, but minus x, whatever, okay, let me direct integrate this without substitution, that will be better. If I direct integrate this, just assume that 1 minus x, what is the coefficient of x? Minus 1. We will divide that by minus 1 after integration. So it is taken as 0 to infinity. It is 1 minus x whole power minus 2 into dx. Or we can write it as x minus 1, doesn't matter because it is square. So minus sign doesn't matter. Okay, so because it was positive value, so x minus 1 it can be taken. But integration of this will be done. Okay, this is minus 1 plus 1, minus 2 plus 1, sorry. So it's minus 1 only. It is 1 minus x minus 1 upon minus 1. But divided by minus 1, which is plus 1 here. It is multiplied by minus 1. Why? So the coefficient of x is minus 1. Here it was 1 minus x is equal to minus 1. Then divided by the same index, this is minus 1 here, and we have taken here inside. So this is value 1 minus x. This is positive. What does it mean? Limits are 0 to infinity. This is 1 upon 1 minus x. Okay, this is positive value. Minus 1 into minus 1 and 0 to infinity. Now in this case, so this is infinite limits. Limits are infinite, undoubtedly. And this function is bounded, not bounded. So at 0, at lower limit it is bounded, because if I put x equal to 0, at upper limit it is okay, 1 upon infinity. This is 1 upon minus infinity, that means 0 here. If I put upper limit 1 minus infinity, okay, that means minus infinity, that means 0. Okay, and this is minus plus, or the minus sign, let me write in between. This is 1 only. At least this function is bounded here. Okay, so condition is function bounded and limits are infinite. Okay, both conditions are satisfied here, because in case infinity, function was bounded. This is bounded, unbounded also. At one point function is not bounded, but at this single point function is bounded here. If I take x equal to 1, suppose 0 to 1, if I take any between, so let me take epsilon here. Okay, if I take 0 to epsilon, where epsilon tends to 0 to epsilon, okay, or 1 minus epsilon, doesn't matter, and plus sign, this is 1 upon 1 minus x again, and this is epsilon or delta tends to, if I take delta to infinity, this is delta to infinity. If delta equal to this, what will be the values here? So 1 upon 1 minus epsilon, this one, okay, minus sign, this is 1 upon 1, negative sign, plus sign, upper limit is infinity, so this is 1 upon 1 minus infinity, this is the upper limit here, and lower limit is this minus sign, 1 upon 1 minus, this is 0 here, because delta tends to 0. So these values, if delta equal to epsilon, so these two values will cancel out. This is minus 1 only, and this is minus infinity, sorry, 0. But this is 0 here. So value exists. This is of third kind. If the both conditions are satisfied, region, the function is bounded. Okay, this function is not bounded at this point, but bounded, as well as limits are infinite. This is a third kind of improper integral. It is an improper integral of third kind. The second question is improper integral of third kind. Okay, so both conditions are included in this question. This is improper integral of third kind. Question number 4. This one is third kind of improper integral. Third kind of improper integral. Third kind of improper integral. Now, let me talk about question number 5. What does question number 5 say? Okay. Question number 4 we have done. Now, 5th one. So that minus 1 to plus 1 dx upon x square does not exist. Okay. This we have to solve. So that minus 1 to plus 1 limits dx upon x square does not exist. Okay, into dx to show does not exist. So that it does not exist. To show it does not exist. Does not exist. Okay, let me take whether this exists or does not exist, that we will define. But how can we express this question? So this question can be written as minus 1 to, let me take the plus 1, this is dx upon x square. We can write this question in two terms, minus 1 to 0, let me take, into dx upon x square, plus sign, this is 0 to 1, and dx upon x square. Or we can write here 0 minus epsilon. Okay, so let me take what is this function. Does it exist or does not exist? If I integrate this function, this is minus 1 upon x integration. Well, if I take x minus 2 in the numerator, integration of this will be whatever 0 to, this is minus 1 to plus 1. Or integration of this value. If I, limits are there, but if it is x raised to power minus 2, because I have taken in the numerator, so this is x raised to power minus 2, integration of this will be x raised to power minus 1 plus minus 2 plus 1 upon minus 2 plus 1. That means it is nothing but 1 upon x only, negative. This is minus 1 in the denominator. This value will be x raised to power minus 1, that means 1 upon x, minus 1 upon x. Integral of this is minus 1 upon x. This is nothing but minus 1 upon x, or limits minus 1 to 0, let me take. This is plus sign, also minus 1 upon x. And if I take this epsilon, this is delta. Okay, so in that situation, let me take here epsilon here and limit epsilon tends to 0, and this is epsilon here by Gauss's first principle. and this is delta here. Let me take, or 0 minus delta, that doesn't matter. So this is 0 minus 0 plus delta, this is 0 minus delta, minus epsilon. Sorry, this is now delta to 1, and here delta turns to 0. Okay, limit here delta turns to 0, your limit epsilon turns to 0. Okay, so this we have integrated. Now let me solve it further. This is minus 1 upon epsilon, first one. If it is 0, then it is infinity, not defined. And this is minus minus plus 1 only. This is minus plus here. Why? Because in between we put minus sign. This is minus sign already, so this is plus sign. So plus 1 upon 1, lower limit. Lower limit, sorry, this is negative. Different negative is there. Minus sign already there. In between we put, and this is minus sign. So this is negative. I'm sorry. This is negative. Triple negative here. Why? Because minus sign. Negative minus 1 in the denominator, and in between we substitute, when we substitute the lower limit, and we put here minus sign in between. So there are 3 negative signs. They are negative. Plus, what about this one? Here delta turns to 0, and if I let me write here, epsilon turns to 0. Here also delta turns to 0. Both are same thing. Here also delta turns to 0. This is minus 1 upon 1 only, upper limit. This is negative 1. And this is minus sign 1 upon delta, where delta turns to 0. This is also minus infinity. This is minus infinity, but delta turns to 0. This is minus 1 and minus 1 and minus 1, this is minus 2 here. Question number 6. So that this does not exist. Is it plus 1, minus 1? First one negative value, and this lower limit, if we substitute, it was negative here, minus 1. Okay, first is minus 1 here, negative sign, and this is plus 1. So this value, in this case, this is negative, right? This is minus infinity. Even if I take minus 2 and this is minus infinity, when we add with minus infinity, so it is minus infinity only. Twice minus infinity, that means infinity only. The function is not existing in between. For this value, minus 2, minus infinity, that means infinity. The function does not exist here. Even if I do not take any middle point here, minus 1 to plus 1, okay, or if I take 0 in between, that also will define it. Minus 1 upon x here, direct in infinity, this is minus 1 to plus 1. Now let me substitute these limits. First value is positive 1. This is minus 1 here. For the integration of this is minus 1 upon x. Okay, so minus 1 upon x. First substitute the limits. Upper limit is plus 1. This is plus 1 here. 1 upon 1, that means minus 1 only. Then in between we put minus sign. It is minus 2 here. The value is 9. That means value exists. It's minus 2 here. But if I take in between 0, epsilon 0, that was minus infinity. We will have to show that minus 1 to plus 1 here on axis here does not exist. It says does not, but it exists. Okay, how it can be said that it does not exist? In general sense, or if I take delta equal to epsilon, then it is 0, 0. In that situation, this is infinity in that situation. So at 0, it is not defined. In between, the function is not defined. Okay, but if I take no limits in between, at x equal to 0, the function is not defined. Does not exist. The improper integral does not exist. So the improper integral, this is improper integral. The improper integral, because limits are here, finite limits minus 1 to plus 1, but at 0, at least at one point, the function is not defined. Is is the function is improper. The function is improper. The function is improper. We have to say is improper. This is improper integral. Okay. So at x equal to 0, the function is improper, or the integral does not exist. The integral does not exist. Okay, so this is what we call at 0. If I take marginal to 0 and 0 to 1, at 0 it is infinity. 1 upon x is infinity. Okay, because 1.0 is infinity. So at that situation, function does not defined, does not exist in between. You say so that -1 to +1, this function does not exist. So in between, the function is not existing. That can be said. But at -1 and +1, the lower limit and upper limit, the function is defined. The function exists, does not exist at lower limit or at upper limit. That is those two functions, those two conditions we will define later, but let me first solve it. And I've just defined that in between the function is not defined, does not exist. Okay, at 0 it does not exist. Now let me take next problem. Question number 6 now. Does the improper integral this exist? Okay, let me take question number 6 here. We have to just check whether this is now -1 to +1. Limits again. And integration of this function, this is actually for 2/3. Okay, let me take it in the numerator. This is -2/3 here. I'm sorry. Now I've taken this denominator into the numerator, and the power will be negative. This is -1 to +1. Okay, so integration of this will be actually for -2/3 +1 upon -2/3 +1. Now limits are -1 to +1 if I take, or we can write it within two limits in the same way as this is 1.3. So this is 3 into actually for 1.3, positive 1.3. Why? But -2 + 3 upon 3, that means 1.3. Similarly, divided by 1.3, that means 3 will come in the numerator. Okay, so this is -1 to 0 if I take, plus sign in between if I take, or these two points are either epsilon or this is delta when these two are equal. In general sense or in